Hi everyone, this is Sandeep Srishan and you're watching Astrobyte Engineering. In my last video, we were discussing Android Room database. So we will be continuing with the same application and we will be including Kotlin coroutines. In the Room database, all CRUD operations should not be performed in the main thread. We should write those in separate threads. For this, we can either use async task or Kotlin coroutines. Since async tasks are deprecated in Android as it may lead to memory leaks, so we are going to use Kotlin coroutines in our application. Let's remove this line from code. Now we can just run the application. As you can see, the app got crashed. This is because the database cannot access on the main thread since it may potentially lock the UI for a long period of time. So for this, we need to use Kotlin coroutines. So a coroutine is a concurrency design pattern that you can use on Android to simplify code that executes asynchronously. On Android, coroutines help to manage long-running tasks that may otherwise block the main thread and cause your app to become unresponsive. The main features of Kotlin coroutines are they are lightweight, they have fewer memory leaks, they have built-in cancellation support, and we can easily integrate to Jetpack. Let's dive into the code. So previously we have created a notepad application using Room database. If you have not watched my previous video, please do watch it and come back so that you will get a better understanding. In order to support Kotlin coroutines in our application, we must add these two libraries in the build.gradle file. The first one is the org.jetbrains.kotlin.x coroutine and the second one is AndroidX lifecycle runtime. Let's sync the project. So the project is synced now. Now let's go back to our main activity. Here, as you can see, this function getAllNodes is a CRUD operation which is currently working on the main thread. So we should move this to the background thread. For that, let's add some more code. Let's add global scope dot launch and we will add this code inside this. So let's run the application again. Now the app started working perfectly. So you might be wondering, what is this global scope? Let me discuss that. The scopes in Kotlin coroutines can be defined as the restriction within which the Kotlin coroutines are being executed. Scopes help to predict the lifecycle of the coroutines. There are basically three scopes in Kotlin coroutines. They are global scope, the other one is lifecycle scope, and the third one is view model scope. Global scope is one of the ways by which coroutines are launched. When coroutines are launched within the global scope, they live long as the application does. The maximum lifetime of the coroutine is equal to the lifetime of the application. Coroutines launched in the global scope will be launched in a separate thread. Since the coroutine is using the resources of the activity in which it is launched, and now since the activity has died, the resources will not be garbage collected as a coroutine is still referring to that resource. This problem can lead to a memory leak. So using global scope all the time is not always a good idea. So let's change this code with using lifecycle scope. So in lifecycle scope is same as the global scope, but the only difference is that when we use the lifecycle scope, all the coroutine launched within the activity also dies when the activity dies. It is beneficial as our coroutines will not keep running even after our activity dies. In order to implement the lifecycle scope within our project, just launch the coroutine in lifecycle scope instead of global scope. That is, just change the global scope to lifecycle scope in the main activity. All the code will remain the same. So let's change this global scope to lifecycle scope. Lifecycle scope dot launch. Inside this, we would add this dispatcher dot. Since we are working on input output operation, we will be using IO input output dispatcher. So let's run the application again. Now the app works perfectly. Even if the activity is closed, the lifecycle scope will also get dice, so there will be no memory leaks here. Now we have added lifecycle scope to this function. So there are other functions, CRUD operations as well. So we need to add this line of code to all those CRUD operations. Let's add it here and here. Cut all these CRUD operations and paste it here. Yeah, that's it. Let's run the application again and let's check all the functionalities. So let's add a new node. Open gate at 5 p.m. The app got crashed. The reason for ANR is due to this dispatcher. We are currently using dispatcher.io, which is working in another thread. So in the same function, we are updating the UI here. So it should not be done. For that, we need to update the dispatcher to main. So we should write like dispatchers.main. And we need to update the build.gradle with Android X room KTX. This is a library used in the room database along with coroutine. So we need to update the code in the notepad data access object with suspend function. Suspend function is a function that could be started, paused, and resumed. One of the most important points to remember about the suspend function is that they are only allowed to be called from a coroutine or another suspend function. So let me add this to all those functions and we need to update it with dispatcher.me. Yeah, that's it. Before that, we need to sync the project and let's run the application again. Let's add a new node. Yeah, the app is working fine. So that's it for this video. Thanks for watching.